And you found the quick review, multiplying matrices. And remember, you have to think of the thought across and down. All right, some preliminaries. We have a 2 by 3 times a 3 by 2. Remember, in order to be able to multiply matrices, the columns of the first must match the rows of the second. If that's not the case, you cannot multiply them and there's no solution. All right? And then also, remember that the final matrix will have dimensions of the rows of the first and the columns of the second. So when we multiply these, we should end up with a 2 by 2. All right, let's get right down to it and see if we can do it. So what I'm going to do is I'm going to work across this row and down this column. And that's going to be my first element, those three multiplications, across and down. Okay, so 6 times 3, right, 18, and then 5 times 1 is 5, and then 4 times negative 1 is negative 4, all right? And so that's the first across and down, right? Now I like to do my second column as well, and now I got to take across this first row and down this second column. Okay, so I'm still on top right now. 6 times negative 2 is negative 12, right? I'm doing this. And then 5 times 5 is 25. And then 4 times negative 3 is negative 12. Okay, and that is the second across and down, right? Now I got to work across the bottom. So now I got to go across the bottom, again, down the column, right? Cross and down. So I got a negative 1 times a 3. I got a 2 times a 1. And I've got a 3 times a negative 1. All right, that's first element. And then again, I'm going to work across and down. So across I go. Negative 1 times negative 2 is a 2. 2 times 5 is a 10. And 3 times negative 3 is a negative 9. Okay, now all I have to do is simplify everything up. 18 and 1 is 19. Negative 24 and positive 25 is 1. Negative 6 and 2, I believe that's a negative 4, and 12 and a 9 is a 3. And of course, notice we did end up with what we expected, that 2 by 2. So across and down, across and down. All right, don't forget the identity matrix. It'll always have a 1 in the top left corner, and then the ones will go diagonal. Everything else will be zeros. And as you remember, the identity always gets you back to the original. So if I were to multiply these out, I should end up with the original. And, you know, we notice here we have what, a 2, whoops, hate when it does that, 2 by 3. And here we have a 3 by 3. Notice our middles match, and we'll end up with a 2 by 3. We should end up with the exact same matrix. All right, so I'll do this a little fast. 6 times 0 is 6, and then you have 5 times, or 6 times 1 is 6, then 5 times 0, 4 times 0. That's first element. And then 6 times 0 is 0, 5 times 1 is 5, and then 4 times 0 is 0, and then 6 times 0 is 0, 5 times 0 is 0, and 4 times 1 is 4. And notice how that top row, right? And again, look, I'm just working across and down. When I do this first column, I get the negative 1 times 1 is a negative 1, everything else is 0. When I work this second column, the first is 0, the 2 times the 1 is the 2, right? And then the other one's a 0, and you can see how it just works itself. And so that last across and down gives you that 3, and notice how we did indeed get back to the original. Multiplying matrices, it's different from scalar multiplication. We're actually multiplying matrix times matrix, across and down. But don't forget, for it to be possible, the columns of the first must match the columns of the second, and the final matrix dimensions will be the rows of the first and the columns of the second. All right, that's the concept.